In the 8th episode of 10 Years on Mars, Curiosity uncovers ancient relics, captures mysterious images during the night, and discovers bright particles on the Martian surface. This is the story of Mars, a red, barren, and mysterious world. But beneath its surface lie echoes of the past, evidence that water once flowed here, that conditions for life may have existed, and that Mars, despite its harsh transformations, has guarded its secrets for billions of years. Today, we'll follow the journey of the Curiosity rover, part of NASA's Mars Science Laboratory mission, and explore the astonishing discoveries it has revealed. If you're watching this video for the first time and haven't subscribed yet, then subscribe now so you can benefit from our upcoming stories and be the very first to receive them. Stay with us until the end, because at the end, we'll reveal a secret that will truly amaze you. Don't forget to like, share, and comment, because you are the real strength of this journey. On August 6, 2016, Curiosity touched down on the Martian surface inside Gale Crater at a site later named Bradbury Landing. This was no ordinary landing. A sky crane system carefully lowered the rover onto the soil of Mars, a feat of engineering unlike anything before. In the very first Martian days, Curiosity's cameras revealed something extraordinary at Goulburn Scour: pebbles and rocks shaped by water, clear signs that streams once flowed across this crater floor. At the base of Mount Sharp, the central mountain of Gale Crater, the rover's images showed layered rock formations, just like those shaped by rivers and lakes on Earth. Curiosity then drove toward Glenelg, stopping at an area called Rocknest, where it scooped Martian soil for the first time. Scientists noticed tiny, bright particles in the sample. At first, they suspected spacecraft debris, but later analysis showed these were Martian minerals, likely silica and other native compounds. When heated, the samples released about 2% water by weight, along with carbon dioxide, oxygen, and sulfur compounds. This was the first clue that even the dry soil of Mars holds hidden moisture. Then, at the John Klein site, Curiosity drilled into bedrock for the very first time on Mars. The powdered rock sample was carefully delivered to the rover's onboard laboratories, opening the door to the planet's chemical history. As Curiosity began ascending Mount Sharp slopes, scientists expected to find only dry, wind-sculpted rocks. Instead, they uncovered evidence of ancient lakes and rivers, even at higher elevations. Mount Sharp is built of sedimentary layers, each one a page in the history of Mars. They reveal that the planet's climate has shifted over time. Once wetter, then drier. Once supportive of rivers and lakes, later dominated by ice and dust. And now, the latest revelations. Discoveries that reshape how we view Mars's past. 1. Carbonate minerals. Curiosity has detected high levels of siderite, FeCO3, in Martian rocks, sometimes over 10%. This suggests Mars once had an atmosphere rich in carbon dioxide, capable of sustaining liquid water for extended periods. Large organic molecules. At Yellowknife Bay, Curiosity drilled into ancient lakebed mudstone and found some of the largest organic molecules ever detected on Mars. Long-chain alkanes, such as decane, undecane, and dodecane. This shows that Mars can preserve organic compounds for billions of years. Coral-like rock formation. A small branch-shaped stone was found in Gale Crater, resembling coral. This unique shape was created by mineral-rich fluids seeping into cracks, later evaporating, and finally sculpted by Martian winds. Boxwork patterns, nodules, and ridges. On Mount Sharp slopes, Curiosity revealed boxwork terrain, patterns formed when minerals filled fractures in the rock. Over time, softer material eroded away, leaving behind raised ridges and nodules. These are strong clues that fluids once moved deep underground on Mars. Panoramas and weather monitoring. Recently, Curiosity captured a stunning panorama of Gale Crater, with its northern rim in clear view. Using its mast cam, scientists processed the images to match what human eyes would see on Mars. The rover also continues to track Martian weather, dust storms, seasonal changes in atmospheric clarity, and icy aerosols rising into the thin sky. These observations help us understand how Mars's climate still evolves today. But mysteries linger. Even though we now know that Mars once hosted water, rivers, and lakes, we still ask, did life ever begin there? The presence of organic molecules and carbonates shows that the chemistry was right. But a true biosignature, unambiguous evidence of life, remains elusive. The changing climate on Sol 28. Rock layers tell us that Mars's climate shifted dramatically, from wet to dry, from warmer to freezing cold, and from potentially habitable to harshly uninhabitable. Rover's longevity and challenges. Curiosity's mission was designed for just 2 years, yet it has now worked for more than 13. Its instruments, batteries, and wheels show signs of wear, but engineers continue to adapt, extending the rover's remarkable life. Curiosity's discoveries strengthen the case for bringing Martian samples back to Earth. Only in advanced Earth laboratories can we run the precise isotopic tests needed to determine if signs of life are truly hidden within Mars's rocks. Curiosity has shown us that Mars is not just a dead, dusty world. It was once alive with rivers, lakes, and the potential for life itself. Its rocks are history books, recording the planet's changing climate, its lost water, and the ingredients of life. As Curiosity continues its climb up Mount Sharp, it carries humanity's greatest question. Was Mars ever a home for life? Its greatest gift may not be the answers it has given, but the deeper, sharper questions it leaves us with. The search for life is far from over. In fact, it has only just begun. What do rocks tell us? These rocks are not just solid stone walls. They are natural recording devices. When a volcano erupts and lava flows, it cools down and hardens into rock. When rivers carry soil and sand to the mountain's base, over time, those layers are locked inside the rocks. When winds and snow carve through the mountains, they leave their signatures etched upon the stones. These newly discovered rocks are special in their density and weight. It feels as if the Earth reshaped them under immense pressure and temperature, forging them into something unique. These rocks hold answers to many scientific questions. 1. Mineral composition. Research shows that they are rich in feldspar, quartz, and iron-bearing minerals. Such minerals form deep within Earth under intense heat and pressure. This reveals that these rocks were once trapped in the planet's depths before slowly being pushed upward. 2. Signs of natural erosion. Their surface carries fine lines and rough textures, evidence of thousands of years of rain, strong winds, and snowfall shaping them. They are like a natural map, telling us how climates shifted over time. 3. Traces of water. Some rocks show tiny tunnels and bubble-like cavities, signs that water or steam was once present when they formed. Perhaps these places were once ancient lakes or flowing rivers. For scientists, these rocks are like a time machine. Their layered structures reveal which era each layer belongs to, like chapters in a book narrating Earth's history. Through radiometric dating, Scientists can measure how many millions of years old they are. And if traces of microfossils or organic remains are found, they provide clues about ancient life. This research is not just about Earth. Studying such rocks also helps us understand the story of Mars and other planets. Imagine touching a rock that seems ordinary, but in reality, it is a billion-year-old memory. Inside it lies the heat of ancient volcanic lava, the flow of long-lost rivers, and the silence of passing time. This discovery reminds us that Earth is never still. It is always moving, always transforming. These stones are not silent. They are witnesses of history. They tell us how Earth was formed, how it changed, and how it became a home for life. Now, the question is, can we truly understand their language? Or has Earth still kept some of its secrets hidden? Friends, thank you for joining us on this journey. If you enjoyed this video, make sure to subscribe to the channel so you never miss the stories that come next. Share this video with others, because knowledge only grows when it is passed on. And believe me, our next documentary will be even more fascinating, revealing secrets of Earth and the universe like never before. What did you learn from this video? Share your thoughts in the comments, because your voice is the true strength of this channel. This is not just a video. It's a continuing story of knowledge, and you are an essential part of that story.